Welcome to the pre-calculus notes for rational functions of asymptotes for chapter 2.6. Go ahead and write the title and then print your first and your last name and what period you're in. So we're going to be graphing some more of these rational functions. If you want to open up a tab for Desmos, you can. So the first example, we're going to have the function x over x squared minus 2x minus 15. To get the vertical asymptote, we're going to take the denominator and set it equal to 0. We're going to factor it, and we get x minus 5 and x plus 3. Then what number plugs into each of them to get 0? So we have a vertical asymptote at positive 5, and 1 equals negative 1 at x equals negative 3. So the domain is going to be all real numbers except for 5 and negative 3. So you can dash your vertical lines in there. The horizontal asymptote, you're going to find the exponent of the numerator, which is 1, largest exponent of the denominator, which is 2. So 1 is less than 2. That means your horizontal asymptote is at y equals 0. It's red dashed right there. Okay, so to find our x-intercept, it's just 0, where the numerator is 0, so x equals 0. To get our y-intercept, you plug in 0 into the whole function. So 0 over 0 squared minus 2 times 0 minus 15. Okay. And then if you want to find some exact points, you can plug in the different numbers. You can plug in negative 2, positive 4, positive 6, get different points. Or you can go to Desmos and help you get a few points. Okay? All right, here's one that you haven't seen before. So we're going to have the function 6x minus 24, which factors to 6 times x minus 4, over the trinomial x squared minus 2x minus 8. If you factor this trinomial, you're going to get x minus 4 and x plus 2. Notice that the x minus 4 and the x minus 4 are factors that will cancel. This means that there is going to be a hole in the graph at that point when you set it equal to 0. So if you set x minus 4 equals 0, add 4 to both sides. At x equals 4, which is over 1, 2, 3, 4 right here, you're going to have a hole. See how there's a hole in the graph? Okay. Then to get your vertical asymptotes, you're going to take the denominator, set it equal to 0. We already know factored. It's x minus 4 and x plus 2. There's a hole there, so it gets crossed off. Okay. So you're going to have a domain of all real numbers except when x equals 4 and when x equals negative 2. To find the horizontal asymptotes, the largest exponent of the numerator is 1, of the denominator is 2, and 1 is less than 2. So your horizontal asymptote is at y equals 0. Your x-intercept, there is none. Okay. Your y-intercept, you plug in 0 into both the numerator and the denominator. Simplify it, you should get positive 3. So on your y-axis, you go up to 1, 2, 3. There's a point roughly right there. And if you want to figure out a few more points, you just plug in those numbers. And then double check your answers on Desmos. Okay. Next example. Plug him out. All right. 12x plus 36 over x squared minus 9. And I factored out the 12 in the numerator and factored the denominator. So there is a common factor of x plus 3. If you set those equal to 0 and subtract 3, you're going to see that there's going to be a hole at x equals negative 3. So if you go over 1, 2, 3, you're going to notice there's a hole right there. Okay. All right. That leaves us with 12 over x minus 3. This function right here. Okay, so for this function, we're going to get a vertical asymptote by setting the denominator equal to 0. That means there's a vertical asymptote at positive 3. 1, 2, 3, there it is in blue. Okay. Horizontal asymptote, largest exponent of the numerator is 1, denominator is 2, so 1 is less than 2. That means your horizontal asymptote is again at y equals 0. That one comes up a lot. There's no x-intercept. Y-intercept is when you plug in 0, and you should get -4. And then if you want any other points, you can plug in numbers and graph.